Good day everyone, I am Arvin J. Emilio from BSED Math 3B, and for today I will be discussing the Kruskal-Wallis test. So, let's get started. So to start our discussion, let us first define what is Kruskal-Wallis test. So Kruskal-Wallis test is a hypothesis test that checks whether there is a difference between several independent groups. So you may wonder a little bit and say, oh, if there are several independent groups, then I use analysis of variance. That's right, but if your data are not normally distributed and the assumptions for the analysis of variance are not met, we use Kruskal-Wallis test. So Kruskal-Wallis test is considered as the non-parametric alternative to the one-way ANOVA or one-way analysis of variance. So now, let us try to enumerate some important differences between ANOVA and Kruskal-Wallis test. So analysis of variance checks whether there is a difference between the means. So if we have our groups, we calculate the mean of the groups and then we check if the mean of the groups are equal. So on the other hand, Kruskal-Wallis test checks whether there's a difference in rank sums or rank totals. So here, we don't check if the means are equal, but we check if the rank sums of the groups are equal. Now, what is rank and what is rank sum? In this test, we sort people by size. The person with the smallest value ranks 1. The person with the second smallest value ranks 2. The person with the third smallest value ranks 3, and so on and so forth. Now we have already assigned a rank to each person, and then we can simply add up all the ranks from the first group, from the second group, and from the third group. In this case, we got the rank sum of 39 for the first group, 44 for the second group, and 37 for the third group. So here in Kruskal-Wallis test, the big advantage is that we do not look at the mean difference but at the rank sum. So the data does not have to be normally distributed. So when we use this test, our data does not have to satisfy any distributional form. Also, in this test, each sample size must be 5 or more. In these situations, the distribution can be approximated by the chi-square distribution with k-1 as degrees of freedom, where k is equal to the number of groups. So when do we use this test? We use Kruskal-Wallis test when we have a nominal or ordinal variable with more than 2 values. So for example, we have cell phone brands, television frequencies, etc. And if we have a metric or ordinal variable, such as salary and weight. So now, what are the assumptions in this test? So first, only several independent random samples with at least ordinally scaled characters must be available. And then, second, the variables do not have to satisfy a distribution curve. And third, null hypothesis, there's no difference in the rank sums. And alternative hypothesis, at least one group differs in rank sums. So now let's proceed to example 13-6. So milliequivalents of potassium in breakfast drinks. So a researcher tests 3 different brands of breakfast drinks to see how many milliequivalents of potassium per quart each contains. These data are obtained. So under brand A, we have 4.7, 3.2, 5.1, 5.2, and 5.0. Brand B, we have 5.3, 6.4, 7.3, 6.8, and 7.2. Under brand C, we have 6.3, 8.2, 6.2, 7.1, and 6.6. So at alpha 0.05, is there enough evidence to reject the hypothesis that all brands contain the same amount of potassium? Now let us start to solve for this. Step 1. State the hypothesis and identify the claim. So for our null hypothesis, there's no difference in the amount of potassium contained in the brands. This is also our claim. For alternative hypothesis, there's a difference in the amount of potassium contained in the brands. Now let's proceed to step 2. Find the critical value. Use the chi-square table G with degrees of freedom k-1 with k is equal to the number of groups. So with alpha that is equal to 0.05 and degrees of freedom that is equal to 2, the critical value is 5.991. So now we will be proceeding to step 3, compute the test value. So for letter A, arrange the data from the lowest to highest and rank each value. As we can see here, 3.2 is the smallest value, that's why it is ranked as 1. 4.7 is the second smallest value, that's why it is ranked as 2. And 5.0 is the third smallest value, and it is ranked as 3. And so on and so forth. Now for letter B, find the sum of the ranks of each brand. So we will be needing this table. So we will look for brand A first. So we have the ranks 1 plus 2 plus 3 plus 4 plus 5, that is equal to 15. So for brand B, we have the rank 6 plus 9 plus 11 plus 13 plus 14 equals 53. And for brand C, we have the rank 7 plus 8 plus 10 plus 12 plus 15, that is equal to 52. So for letter C, we'll just substitute all the values to this given formula. We have H is equal to 12 over N quantity N plus 1, quantity R sub 1 raised to 2 over N sub 1 plus R sub 2 raised to 2 over N sub 2 plus R sub K raised to 2 over N sub K minus 3 quantity N plus 1, where N is equal to N plus 1 plus N sub 2 plus N sub K. R sub K is equal to the sum of the ranks for kth group, and K is equal to the number of groups. Now here are the values that we need. So we have N is equal to 15, R sub 1 is equal to 15, R sub 2 is equal to 53, R sub 3 is equal to 52, N sub 1 is equal to N sub 2, and equal to N sub 3, that is equal to 5. Now, substituting all the values in the formula, we will have 12 over 15, quantity 15 plus 1, quantity 15 raised to 2 over 5 plus 53 raised to 2 over 5 plus 52 raised to 2 over 5 minus 3, quantity 15 plus 1, and that is equal to 9.38. Therefore, our test value is equal to 9.38. So after computing, we will now proceed to step 4. We will make the decision. So since the test value 9.38 is greater than the critical value, which is 5.991, the decision is to reject the null hypothesis. Let's proceed to the last step, which is step 5, summarize the results. Since we reject the null hypothesis, there's enough evidence to reject the claim that there's no difference in the amount of potassium contained in the 3 brands. Hence, not all brands contain the same amount of potassium. So that ends my presentation for today. Thank you so much for listening, and I hope you've learned something from what I have discussed. Keep safe and God bless.